I've always found it very important when we talk about ChatGPT to understand the context, to understand what this tool is. What is its external context? Why did it emerge? Generally, people who are less experienced with technologies that seem magical, like ChatGPT, which launched in November 2022, there was all that hype that it seems like something magical, like a human talking to you, because the answers are amazing. It seems that up until the Turing test, where you test if that machine, if that interface answer like a person so you can assess if they are indeed a person. Tools like Gemini, Metas, Llama 3, Grok. This one below here, which is Elon Musk's G-Cloud 3 from Anthropic, are types of LLMs. Which is this term here? Large language models. Which are large language models. We have a whole context behind it to understand how it came to be. So what was the cradle of artificial intelligence that led to these models' existence? So, in the historical context, folks, here we have 2017. Google released a paper about what transformers are. Transformers are the basis for the creation of LLMs. OpenAI, the creator of ChatGPT, this one here was. If I'm not mistaken, I was one of the pioneers in creating these language models. The model that was ChatGPT, which released version 3.0 to the public, became widely known. This version she made available to people, both amateurs and those who understood how artificial intelligence worked. Everyone was a bit startled by how human-like it seemed when talking to you. The accuracy of the information wasn't evaluated much because the conversation was so fluid, so cool to chat with. Gita, a machine that wasn't a dumb robot, let's say, right? So, like, GPT 3.0 was, if I'm not mistaken, a kind of marketing stunt, a strategy by OpenAI to improve their model. Though here we have a slightly more technical part, which is related to separating training from inference. When a language model, when training an LLM model, it undergoes various modeling and alignment according to ethical and moral guidelines. Anyway, all those not safe for work terms. I'll put it down here for you. So, there's a need for technical alignment, moral alignment, legal alignment. These tem pericuteixi. You need to follow this model because it's trained based on various documents from the internet, which can have content that is not necessarily hypocrisy. Let's put it this way. That follows the ethical, moral, and legal norms from our world, right? This will be a topic a bit later in the video. But now I want to go back a bit to the historical context of how artificial intelligence works as a whole. First, let me introduce myself. Yeah? I am Marcel. I have been working in technology for about 13 years, starting with PHP programming, my SQL database, and in the last 8 years, I started working with the C# language and SQL Server database to work with ETL pipelines, extraction, transformation, and loading of data in SQL Server databases. And in the last 5 years, I have worked more with Python language and slightly more elaborate pipelines for more efficient data extractions. And also, in the last 5 years, I studied a lot about artificial intelligence with the Python language, specifically in the area of machine learning. It's a stage just before deep learning and LLMs. And so back here to in our historical context of how it works, about how AI has emerged over time, what the first stages were like, what the first studies were like. The starting point that I understand as the most important was the perceptron in the 1960s when it was created. For teaching purposes, to avoid creating something too technical, very well founded, very difficult to understand, I created some examples below as well of images. So you have an idea of what this model was capable of doing in its time. So the perceptron, it's kind of like a single neuron that receives instructions, receives inputs, receives data entries, and there's a binary output, which can be 1 or 0. It has no nuances. It's not an output. It's a discrete city, which is only 2 values. So here as an example, we can have the spam box in your email. It's a type of binary classification that can be solved by a perceptron classifier, which is a single neuron that receives multiple inputs and an output that can be 1 or 0. Moving forward to the 1980s, we started with machine learning. We have 2 main models, not just them, but classification one. And the regression model. Let's start with the classification model, which in this example is a classification that involves a database, which is a kind of hello world. Is it a type of entry code for those who want to learn artificial intelligence using machine learning? You start with a problem called distinguishing which number was written manually. So we have an image database, which this one is an example of, which has the numbers from 1 to 1, all 10 numbers, and you need to classify them. What is this number that this person wrote? This right here is an example of classification using machine learning. And we also have the regression example. In this example here, you can calculate how much a house is worth according to its characteristics, with its location, according to its size, how many bathrooms it has, how many bedrooms, kitchen size, type of construction. Here you see that it's not just a big house, right? It also has some windows that seem a bit more expensive than this simple window here on the right, on the left. So it manages to capture these nuances of the data and predict the value of a house based on these parameters, these features. So we have an example here of regression where you need to calculate is according to an imaginary straight lines. You provide some example values for this model to learn from. And with that, he can understand the next values. You can add new houses so that he can evaluate in this model. Moving forward, here we have in the 90s the unsupervised learning models. Here we have the clustering algorithm, which I find quite interesting. In this case here, imagine that you cannot see the colors. You notice that they are clusters of dots that are on 2 axes in 2 dimensions, and that the model has a task which is to try to separate into clusters, separate into groups, which are correlated by the distance between them. So this is a technique called clustering, where the model needed to separate the little balls it's seeing into 3 groups. Here in this model, for example, he separated it into 3 groups by lines that we deductively can separate here visually, right? Which actually has these 3 groups. And if you ask it to separate into 4 groups, it can do it too. But depends on your business model. In this case, let's imagine it as a business model where you need to look for customers by demographics, for example, age group, the kind of game that a person likes to play. Like, let's say someone who recently became a mom and is looking in the market products that are specific for babies, for example. So you can create some clusters of groupings by people who have a correlation of what she is looking for in that establishment, for example. We also have the type of algorithm that is one of the unsupervised types, which is the a priori algorithm. It's a shopping cart where a person does their shopping. And if the person has a prior recommendation about what you need to buy it, and she might have, she will statistically have a higher chance of buying more things in this market. For example, usually, a very famous case that I can't remember which one. When did this happen? This study, Dutch, that checks when a family father with a small child needs to buy some things in the market. They usually put the beers next to the diapers. So why? Because generally, they notice this pattern in the consumption of these parents, which means buying the beer, grabbing the diaper, and heading home. And maybe buying some charcoal, some meat. So these are items that bring people a bit closer together because it has become a routine for these people to get these kinds of things. So, when you see a market that has the positions of things in the market that you think were placed by guessing, it wasn't. There was a whole study behind it to be able to evaluate. Make it easier for the customer to grab the things they need and fill up their cart more. So there will be more sales at that market. Notice that these two algorithms, this a priori and the clustering, are algorithms that are of the unsupervised type. But I haven't explained what unsupervised means. It's a type of algorithm that can detect patterns in the data without someone having to edit the rules for it. That is, it creates its own rules without knowing how the game works. You understand? So that way he will be able to model himself and adjust without having a bias, without having someone who will dictate something that can trend, that can make that information biased. So, I found this evolution here from the 90s quite interesting. Later on, we have deep learning where things started to get a bit more advanced. Here we have several layers of neurons. So, a bit of the technical part for you to understand how this has evolved and advanced. Back in the perceptron step, which you saw earlier, where I mentioned that there was only one neuron that received the inputs and had a binary output that was 0 or 1. So now imagine that this, besides being several neurons, is also several layers. That is, the data flows not only horizontally, but also vertically. Then it goes down through several layers of neurons that are being trained. And that, desse ponto de vista, keep the sheet. You want to say response to previous neural networks I'm studying here. Among the improvements that deep learning brought to us were between 2000 and 2010, there was computer vision, which can detect people, animals, cars, traffic lights, traffic signs, mainly to detect objects. When you see today, for example, Tesla, which is from Elon Musk, it has very elaborate, very advanced technologies to read. Daí, traffic signs. Reading cars, pedestrians, bicycles, children, dogs. Can have a much more elaborate situational awareness to be able to make a decision, tá? About traffic, braking, accelerating, turning, avoiding potholes, for example. So, this here is a very interesting thing. Moreover, in deep learning, we also have GANs, which are generative adversarial networks, which are, in Portuguese, are adversarial neural networks, where one will fight against the other to dar a consensus among them. How does it work? We have this here, this image. I created it to try to illustrate how a machine evaluates. Let's imagine, in this scenario here, this machine wants to evaluate if this is a person or a machine, tá? So like I put in here a character who simulates being a person wearing sneakers, jeans, and a shirt. And this AI needs to check if this here is a human being or not. Then she can ask questions. She can analyze the skin. She can check that here the neck has some metallic parts, the arm too also. So she will assess if this result here will pass her test. And what generated this person, this cyborg, was something else calls this here. Not necessarily another person or a machine, but someone did this here. The job of these adversarial neural networks is where we have a supervisor who will check if what was generated is compatible with reality. So he will have to, this person who is here in this skin, they need to be as convincing as possible so that this robot understands that it is a person. She needs to pass this test. That's why they are called adversarial, because the person who is here needs to be as discreet as possible so she can pass these tests. It needs to demonstrate as much as possible for this robot to speak. Like this, not yes, I am a person. And the robot will analyze this person. It will analyze your way of speaking, your way of moving, your skin, your way of looking, your responses, your thoughts. That's how it will analyze you. This analysis done here, it was a type of study which allowed the images of today. For example, the images you see from tools like Midjourney and tools like ChatGPT itself. DALL-E 2, DO2 or DL3, which is the latest version that this image was generated from, they are just that. They are images that are generated from images that are, let's say, those. You know that TV static you see when a channel is off air? It's kind of like that. So when you make one from that image, you start generating an image that, does it seem real? At the beginning of the training, something very out of reality, like, man, this here can't be real. It's just that these artificial intelligences started to improve to the point that it started to appear that it is real. For example, this image here, if this cyborg were made with a real person's skin, you would even think that, wow, this photo here is possibly real. So, like, it's as if it were an AI that had to improve its output, your output, so that another AI could assess it appropriately. Saying something like this, the image you generated is indeed the reality, because I want to generate more cars. So the image that will rotate through this AI, which is the AI that needs to rotate this car, must be convincing to the point that his evaluator understands that the image is a real car. Okay? Let's then move on here after deep learning. We now have the next stage, which is where we are today. Where you are here in this new era of LLM, of large language models. But that's for later, guys. This AGI era here will be a stage for later. So we have here as examples ChatGPT, Gemini, Llama, Grok, Cloud 3, and Grok. Don't confuse the Grok. This one in black, he is the Grok of Elon Musk. This top-level Grok is another initiative that also involves hardware, the parts that make the model inference. Model inference is when you send a prompt and it gives you a response. That is inference. That's when the model reads your question and gives you an answer. It was a stage where the machine, the CPU, processor, memory, and the video card, which I will explain to you later because the graphics card comes into this context, but it is also crucial both in training and inference. So, moving forward now to artificial general intelligence, AGI, which is a later stage, going back to the context. Then we are today, LLMs, they have the potential to generate a next generation of artificial intelligences called AGI, which is artificial general intelligence. So we have an intelligence, artificial general intelligence. This new era of AI, in my view, it will be built based on LLMs. Why is that? Nowadays, we have some agents that are being created to perform specific tasks. Tasks they are specialists in, and how can this help is the creation of AGI. AGI, just to give you some context, is like an average human being. Bussy, that has the ability to perform common day-to-day tasks. Being able to open a laptop, being able to open an Excel spreadsheet, for example, being able to make a coffee, can send an email, right? I'm not talking about programming itself, like opening a Python script and writing a connection to your SMTP server to send an email. No. I'm saying a robot can open a machine, like abstracting the information from the screen, being able to move the mouse and manipulate your machine as if you were a real person, understand? And this is only in the context of technology, okay? Imagine that AGI can also abstract terms from physics, biology, so for my context here, for my jargon of terms, it would be like it was really a robot, a person, an intelligence that can understand what is happening in that environment and solve problems as if it were a human being. She no longer needs to go through that CAPTCHA that appears on your screen, like you click here to prove that you're not a robot. That will be very easy for her to solve. Those problems of dragging on the screen, a little ball for you to place in a specific position to prove that you are not a robot. It's also a relatively easy task for an AGI era AI to solve it. So folks, this was just some general context for you to understand that LLMs didn't come about in 2022. Neither were born in 2020 nor in 2000. In the 1960s, with artificial intelligence. This was all a foundation so that each of the subsequent steps could improve. We still use classical computing involving CPU, memory, GPU until today. It's okay that Grok is creating a type of infrastructure, a type of hardware that is a bit more elaborate. A technology that, honestly, I don't know how it works in depth. One of the YouTubers replied to me that the creator of Grok with whom was one of the people who worked at Google to create TPUs, which are a type of GPU, specifically for matrix calculations of deep learning. So we already know that it's a bit more elaborate. But why did I mention classical computing? Because nowadays we also have advances in quantum computing. That's why we now have to differentiate what you're talking about in relation to the computing context that uses a CPU, memory, video card, the GPU to be able to do the matrix calculations, or are you talking about quantum computing, which already involves something that, to me, honestly, is still quite out of our reality here. But anyway, our historical context is this. We have a hierarchy of studies, a whole theoretical and practical foundation. We have models here that are really applied in practice so you can use it in your life, in your day-to-day. So you already have a foundation when someone asks you about what is G7EPT, how did it arise, what is its historical basis, right? Did it really come about 2 years ago when it suddenly became this magical thing? No, I don't know if you remember the news right at the beginning when they started releasing ChatGPT to people. That he had many issues with solving simple math problems. Some calculations, for example. If I'm not mistaken, he couldn't add, for example, 15 plus 17. He used to give an answer that was sometimes correct, but if you ask like this, no, that's not the answer. The right answer is 150. He used to say, you're right, it's 150. Why? We now have another context, a little more elaborate. So we have to explain how GPTs were born, how they have been evolving over time. At the beginning, with GPT-3, up to GPT 3.0, they were merely text generators with a statistical basis. It reads the entire conversation context from your initial prompt, which is your question. He starts to respond to you based on what it has already responded to before. So with each word, it generates. With each token it generates, it reads what it has generated and tries to understand what he has to generate next. He tries to predict the next words. That's why in the area of logical reasoning, in the field of mathematics, like simple math, just a multiplication he can't understand because he needs to look into his internal model. Any questions? A question and some answer that looks like what he needs to respond to. He wasn't yet doing an actual mathematical calculation. The sum of 2 plus 2, he didn't know how to do it. He didn't know how to open a calculator and do the math, or do a calculation in programming, for example. What it actually did was search for a text pattern that matched that question. The latest models, like 3.5 and 4, do this masterfully. They actually perform the calculation using logical reasoning. They don't just do a response statistic. They actually do the calculation internally. This is a topic for class, for the next videos, but for now that's it, okay? AI's context is like this until today. Thanks a lot, and see you. And I ended up forgetting, guys, but you saw below. There's an example of Llama 3, right? Llama, for those who know, that's the little critter right here, right? Look at that. My girlfriend said, is this a llama? This one is to represent, this one is to show that nowadays we have some models from Llama. We have version 3 today. Has an 8 billion parameter model, a 70 billion parameter model. And they're soon launching a 400 billion parameter model. I'm surprised by Meta, by Facebook creating such a powerful model like this for free, open source.